This is lecture 6.4. It's all about muscle movements, different types of muscle movements, and how muscles actually cause the skeletal system to move. This first picture shows a bicep muscle, and you can see some important things in this picture. There are tendons at either end of the bicep connecting muscle to bone. There are two attachment points up top here. These are both labeled origin. And then there is one down at the bottom, and this is labeled insertion. I'll talk about what those are next. Every muscle crosses at least one joint. This should make sense because when muscles contract, they're going to be causing a bend to a joint. Every skeletal muscle is attached at least to two different places. Like we saw in the last picture, those places are called origin and insertion. And the difference between origin and insertion is this. When the muscle contracts, the movable bone, which is the one that the insertion is attached to, moves towards the immovable bone, which is where the origin is attached. In other words, the insertion will move towards the origin. This video shows the contraction of the bicep muscle as the arm is lifting a dumbbell. What you can see here is that we have the humerus up top, we have the radius and ulna in the forearm. The muscle is attached both at the humerus and at the bones of the forearm, and when the muscle shortens, when the muscle contracts, it pulls the forearm up towards the humerus. Because of this, we call the connection point down here on the forearm the insertion, because it's going to actually be moving, it's on the more movable bone, and this attachment point up here on the humerus is the origin, since it's on the less moving bone. If you watch this motion one more time, you'll see that the forearm moves quite a bit and the humerus does not. I'm going to put a couple of these quiz questions throughout as we talk about different topics. I'd like you to pause and try to answer this question. I'm not going to go over the answers yet, but I will put all of the answers for all the quiz questions at the end of the video. Here's another one. Now let's talk about types of movements that muscles can cause. These first two types of movement, flexion and extension, are opposites of one another. In this slide, we can see a very simplified joint. We can see that two bones come together, and when they're in neutral position, they are at a 180-degree angle to one another, so in a straight line. We can see that there is a muscle on either side of the joint. And flexion is going to occur when the muscle on the inside of the joint contracts, bringing the two bones closer together. So we're decreasing the angle between two bones. That's your definition for flexion. We went from a 180-degree angle to a 90-degree angle. Flexion has occurred because the angle between the two bones has decreased. As a quick little review from the previous idea, notice that this attachment point on this lower bone would be our origin, and this attachment point on the upper bone is our insertion. Here's a discussion of both flexion and extension. So extension is the opposite of flexion. Everything that we looked at on the previous slide is repeated here with regards to flexion, and then undoing or reversing that movement would be extension. So here's an example. You can see that there is a bend here in the elbow, and the motion that we're going to be looking carefully at is the bending and straightening of the elbow. So in this position, what we can see is that there is a 90-degree angle here at the elbow between the forearm and upper arm bones. And so over here, we can just see a very simplified model. Here's the plane of the body. Here is the upper arm, the lower arm starting out, and the lower arm coming in towards the upper arm would be considered flexion because the angle between the joints is getting smaller. Extension is the opposite. Extension would be, once we have that arm bent, if we were to move it back to where it started. On the left side of this picture, we see someone doing an abdominal crunch. We would consider this back to be extended since it's in a straight line, and we would consider this back to be flexed since the angle between the vertebrae is decreasing. It's no longer 180 degrees. Another type of movement would be hyperextension. So if we were to take this person whose back is in alignment, whose vertebrae are at 180-degree angles to one another, and increase that angle and actually bend backwards, that would be called hyperextension. Next up, we have abduction and adduction. Abduction is, again, we see the midplane of the body here. If a body part is moved outwards away from the midline of the body, that's called abduction. The opposite motion is adduction, taking the body part and moving it back in towards the center of the body. You can see a couple of examples here. If this person were to raise his or her arm, we would have abduction occurring. Lowering the arm back down is adduction. Raising the leg out to the side would be abduction. Bringing it back into the midline is adduction. This person over here is adducting a leg, and this person here is adducting their fingers by bringing them away from the midline. Because your shoulder is a ball and socket joint, it's also able to do circumduction. Circumduction is just the movement of the extremity in a circle. So it involves multiple movements, including abduction and adduction. Here we have rotation. And rotation is going to occur at the neck because at the neck, remember, between your atlas and axis, you have a pivot joint. You have a joint where one bone can spin on top of another bone. Rotating your head from right to left, the way you would if you were shaking your head to say no, is an example of rotation. Here's just a little recap. The hip joint is another ball and socket joint, so again it can perform many different movements. And you can see here what extension, flexion, abduction, adduction, and rotation of the hip would look like. Every muscle movement is a result of muscles shortening or pulling on the skeletal system. Muscles can only pull, they can never push. And because of that, you frequently need to have groups or pairs of muscles at least, so that if you bend a joint one way by shortening one muscle, you're able to reverse that motion and bend the joint the other way. The prime mover or agonist is the muscle that has the major responsibility for the movement. In other words, it's like the bicep when you're flexing your arm. The bicep is the main muscle contracting in order to bend your elbow. On the other side of your elbow is the triceps, and that's the antagonist of the biceps. The triceps is the muscle that would help you straighten or extend your elbow. So the biceps and triceps perform opposite movements. Because of that, they're considered antagonists of one another. The biceps is on the anterior side of the arm, the triceps is posterior. Both attach to the forearm. In this picture, we can see that the bicep is contracting, and that's causing the forearm to get pulled in towards the humerus. Again, this is going to be known as flexion. When the bicep contracts, the tricep on the other side is going to be relaxed. In this picture, the biceps is the prime mover, and the triceps would be the antagonist. Over here we see the reverse motion occurring. We see the arm straightening. So now the triceps is contracting. That's extending the arm. At the same time, the biceps is relaxing. So the triceps here is the prime mover and the biceps is the antagonist. I love this picture. I think it's so cool. This is a person in a yoga pose. And what you can see is that the color coding is showing prime movers in blue and antagonists in red. So in this leg that's flexed forwards, we can see that the angle between the trunk and the leg is 90 degrees. In other words, this muscle had to work to pull the leg in towards the trunk. So this muscle on the front of the leg, which is your quadriceps group, is a prime mover. On the back of the leg is your hamstring. The hamstring is relaxed in this position. Frequently, the antagonist is also going to be the muscle that is getting stretched in a position. So when you are doing a hamstring stretch, you're going to be flexing your quadricep, pulling your leg in the direction of the quadricep, so pulling your leg in towards your body, and that in turn will be stretching out the antagonist, the hamstring. So if you have a hard time figuring out which muscle is working and which muscle is the antagonist, another way to think about this is the muscle that feels the most stretch is the antagonist. Over here on the other leg, it's the opposite scenario. So the back of the leg, the gluteus and the hamstrings, are working to pull the leg backwards. And the front side of the leg is getting stretched. It's the antagonist here. So the hip flexors and the quadriceps are antagonists and are relaxed and stretching. Here's a couple of examples of antagonistic pairs. One that we've just talked about on the previous slide, the hamstring and the quadriceps groups. On the anterior and posterior view of the lower leg, we have the gastrocnemius and the tibialis anterior. Flexion and extension of the wrist, again, happens by, in this case, groups of antagonistic pairs. We have the wrist extensors that are on the lateral side of the forearm and the wrist flexors on the medial side. This picture shows some trunk muscles. We can see that the latissimus dorsi is here. It's a big muscle that is flat, sort of stretched over the middle back. And the latissimus dorsi is an antagonist to a couple of anterior trunk muscles. To begin with, we have the pectoralis over here. The pectoralis is a group of muscles. This is sort of the main chest muscles. And if you've ever done a push-up, you are using your pectorals, essentially extending the arm out in front of you. The muscle that reverses that pulls the arm back down, would be the latissimus dorsi. The deltoid muscle over here on the shoulder, when it shortens, it's going to abduct the arm. It's going to pull the arm up and away from the body. Latissimus dorsi is an antagonist of that as well, because the latissimus dorsi, if your arm is abducted, will adduct the arm and pull the arm back in. Here we have one more set of trunk muscles. The erector spinae on the back are muscles involved in helping you stand up straight. So, in other words, they help to extend your back. On the front, you have your rectus abdominis, which is this main band of muscle right down the middle of the abdomen. And contraction of that muscle is going to flex the trunk. In addition to the agonist and the antagonist, most muscle movements have other muscles involved as well. And some of these are called synergists and fixators. The synergist is going to be another muscle that does a similar movement to the prime mover. So in other words, it kind of helps the prime mover out. The flexor muscles of your forearm, for example, are synergists for your bicep. When your bicep is contracting, the muscles in your forearm also contract to increase the activity of the bicep. Fixators will stabilize the origin bone so that the prime mover is only moving the insertion bone. So here's an example of what that looks like. In this picture, the motion shown is abduction of the arm. The deltoid would be a main muscle involved in this movement. A synergist involved would be the trapezius, because the trapezius helps the deltoid. The trapezius is also involved in muscle abduction. It helps to increase the movement caused by the deltoid. At the same time, we would have all of these fixator muscles engaging right around the shoulder joint to hold the neck and scapula and clavicle in place while the shoulder moves. Here's another review question for you. And another one. Muscle contractions can either be isotonic or isometric. Iso means same, so we're talking about what stays the same during a muscle contraction. Isotonic means that the tension stays the same. Isometric, metric, think meters, means that the length of the muscle stays the same. In an isotonic movement, the myofilaments are able to slide past one another. In an isometric movement, they're not. So the isometric movement has tension increasing in a muscle without actual movement of the insertion bone. Here's what that might look like. The person over here doing the wall squat, imagine that they were leaning against a wall, is contracting their muscles. They're working very hard with their quadriceps and glutes to maintain that position. But despite the fact that their muscles are engaged and working, they're not moving anywhere. So that's going to be an isometric contraction where the muscles stay the same length even though they are increasing in tension. The person doing the pull-ups is doing an isotonic exercise because when they pull on the bar, the insertion bone actually moves towards the origin. Okay, the last part of this unit just involves learning a bunch of names of skeletal muscles. So I have a couple tips for you. This will help you break down the names so that there will be fewer terms for you to just memorize. Frequently, muscle names break down to help you remember something about the muscle. There are parts of the word that reflect something about the muscle. The first group of clues in muscle names is going to tell us something about the direction of the muscle fibers. Anytime you see rectus in a muscle name, it means that the muscle fibers are straight. Over here on the trunk, we can see the rectus abdominis. These are muscles going vertically along the plane of the body. If a muscle has oblique in the name, it's going to be slanted. The fibers are going to be diagonal to the plane of the body. And transverse fibers are perpendicular to the sagittal plane. Muscles can also be named based on their size. So if you see maximus, medius, or minimus, you know something about the size of the muscle. Sometimes the location of the muscle is part of its name. You'll see a lot of names that you learned already in the bones unit. So for example, the tibialis anterior is a muscle that is on the anterior side of the tibia. The rectus femoris is a muscle on the femur, and rectus tells us that it must have fibers that move straight up and down. Some muscle names also tell us about the number of different origins a muscle has. The bi in biceps means 2. The biceps actually has 2 different origins. It attaches to origin bones at 2 different locations. Finally, the shape of the muscle can sometimes be a clue. So the deltoid is named after the Greek letter delta, which is just a triangle. So deltoid muscle is triangular. The trapezius, which is shown in this picture here, is 4-sided. It's a trapezoid. And frequently you'll also see that the action of the muscle is included in the name. So we'll learn about flexors, extensors, adductors, abductors, etc. The next 3 slides are just a list of which muscles you need to know. I'm not going to go over these with you, but you have them. And then the final slide is all of the answers to the multiple choice questions. So hopefully you can go back, check your answers, and make sure that you understood everything.